Good morning. Welcome to Mission Control Houston at NASA's Johnson Space Center. You've got a live view of the International Space Station Flight Control Room and the Orbit 2 team of flight controllers who are on duty to monitor the operation of the station's systems while the Expedition 57 crew members work through the last few hours of another busy week of research operations. Commander Alex Gerst was front and center this week, working on an experiment sponsored by the European Space Agency that is trying to determine how being in a weightless environment impacts an astronaut's ability to literally get a grip on the equipment they use in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. This week, the crew on board was hands-on science. Microgravity provides a unique environment to study dexterous manipulation in an experiment called GRIPS. European Space Agency astronaut Alex Gerst spent time investigating the effects of long-duration spaceflight on humans' ability to grip and manipulate objects. Not only will the GRIPS study help researchers understand the long-term adaptation of grip force and load force coordination that astronauts face, it could also help contribute to the design and control of intelligent haptic interfaces to be used in challenging environments such as deep space as NASA aims to return to the Moon, Mars, and beyond. As the International Space Station closes in on the 18th anniversary of humans living continuously on board, our views inside have never been better. While your neighborhood digital cinemas typically project films in 2 to 4K resolution, this week NASA delivered the first ever 8K footage of astronauts living, working, and conducting research aboard the orbiting laboratory. Thanks to the Helium 8K camera by RED, a digital cinema company, fans of science and space will now be able to follow along in fast-moving footage in even higher definition. Veteran NASA astronaut Mike Hopkins will be riding SpaceX's Crew Dragon to his next long-term stay on the station and is training for his roles once on board. He recently spent time in NASA's Active Response Gravity Offload System, or ARGOS, to practice spacewalking in microgravity conditions. To see the latest as we get closer to these first flights from SpaceX and Boeing, visit nasa.gov/commercial crew. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
While Boeing and SpaceX work to get ready to launch astronauts to space from the USA, just getting off the ground is just the beginning. Once those astronauts arrive at the International Space Station, they'll be working on research to improve life on Earth and help us send humans into deep space, farther than ever before. That was a feature on the Cold Atom Lab facility, which produces atoms that are 10 billion times colder than they would be in deep space. It's a kind of science that's done on the International Space Station by the expedition crews today and will be done by the crews in the future who arrive on the commercial crew vehicles.
The International Space Station, one of the nation's great assets for research and discovery, is in low Earth orbit. And the Commercial Crew Program will be providing transportation to ISS to support that first step as a gateway to space.
The research that we do in low Earth orbit is very important to develop the systems that we'll need and the capabilities that we'll need to protect our crews for these deep space exploration missions.
So the International Space Station is our orbiting laboratory, and it allows us to do research on life and physical sciences and really understand the impact of living without gravity. Because if we understand how organisms respond to gravity and to a lack of gravity, then we'll be able to think about how humans and other organisms might survive on other planets.
It's really a test bed for how do I go away from Earth for 3 years and go to Mars and get back.
Right now, one of the biggest constraints that we have on station is the available hours for astronauts to be dedicated strictly towards research.
And that's why we're so excited by the Commercial Crew Program, because it'll be bringing additional astronauts to the space station, so we're going to have a lot more time to do science.
A lot of the technology we've developed on Space Station has come back here home to Earth in order to benefit people. For example, the robotics that have been so important in the building and the maintaining of the space station have come down to Earth in the form of robotic surgery.
But then think about that crazy day when, instead of just having astronauts that represent NASA interests, you're now able to have private researchers that go up to help and look at research that might enhance life on Earth, or looking at ways to better create drugs or therapies that can improve patient care on the ground. Some would sit there and say that's a wild idea, but that idea is coming closer and closer with every single day.
You get to look there at a lot of the different kinds of science that are conducted on the International Space Station in disciplines from human life sciences and plant biology to technology development and more. But there's one thing that all of these experiments have in common. They are taking advantage of a condition on the station that can't be replicated anywhere on Earth: microgravity.
An out-of-this-world research lab. Presented by Science at NASA. Every now and then when the sun sets, a bright light appears on the western horizon. Gliding silently overhead, it is the biggest spacecraft ever built by humankind, the International Space Station, or ISS, carrying a precious cargo of astronauts around Earth. But the ISS is more than just a bright light in the night sky. It is also an out-of-this-world research laboratory. The interior of the ISS is furnished with laboratory equipment and chambers for experimental research. It's not as large as some Earth labs, but it has one thing that Earth labs do not: microgravity. Gravity influences everything that happens on Earth. It's hard to envision what life would be like without this force, yet removing the pull of gravity can be uniquely instructive. Reduced gravity provided by the ISS is a major attraction for researchers, says Joseph Nugget of NASA's Johnson Space Center in Houston, Texas. The weightless environment allows scientists to gain insight into basic phenomena in many fields. For example, says Nugget, we all have seen that roots of plants grow down into the Earth. Is this because of gravity? Experiments with plants on the ISS can tell us. Understanding how roots grow is directly applicable to space exploration. What does NASA need to consider when designing a plant chamber for food or life support in space? Farmers on Earth are interested too. A deep understanding of roots can help scientists design hydroponic chambers for agriculture in areas with poor soil conditions. Since the first modules of the ISS were launched in 1998, up until 2017, more than 2,400 investigations have been undertaken by over 3,400 researchers in over 100 countries. Astronauts have spent more than 36,000 hours helping run the experiments for scientists back on Earth. To date, more than 1,600 scientific journal and magazine articles have been published reporting the results. It's a scientific bonanza. There are 5 major research areas on the ISS: biological sciences, such as the root experiments; physical sciences; space science and fundamental physics; human research; and earth science. Nugget has favored examples of each. Scientists grow crystals on the station to discover new crystalline forms. Protein crystals grown in small chambers on the station reveal information that helps find new, novel ways to combat disease. The space station is also equipped with furnaces that can melt solid metals and alloys. This can reveal the metal's crystalline structure in a new way and give greater insight into the properties of the material. While protein crystals are a biological science and metal solidification is a physical science, both are examples of how crystalline structure develops in microgravity differently than on Earth. Switching over to fundamental physics, he says, there are several investigations on the ISS that examine fundamental laws of physics and continue the search for theoretical particles. The alpha magnetic spectrometer, for instance, provides valuable data on the existence of dark matter. Human research is also very interesting and dynamic, helping NASA get astronauts ready for deep space exploration with many spin-off benefits for people on Earth. Nugget notes, research like the lighting effect study helps improve our flight team's productivity on the ISS and on the ground here in Mission Control, as well as the many American workers who work on night shift or alternating shifts. One-year missions to the ISS return much information about how the human body adapts to space travel, from the genetic level to how the astronaut deals with the long-term isolation within the spacecraft. Not all research conducted on ISS requires reduced gravity, he notes. For example, the ISS is a great place to observe the Earth. The station passes over the vast majority of the Earth's populated areas. Sensors and cameras on the ISS can contribute to disaster assistance, tracking hurricanes, measuring wind and rainfall, as well as documenting events such as volcanic activity. The ISS, much more than just a bright light in the night, indeed. For more from the International Space Station, visit www.nasa.gov/station. For more news about science on and around the Earth, stay tuned to science.nasa.gov.
The astronauts on the International Space Station spend a good chunk of their time as lab assistants on experiments in that whole range of scientific disciplines. Well, they also devote time to sharing the experience of spaceflight with people on the ground. And that's particularly true when they talk with students and their teachers about science, technology, engineering, and math. In this installment of the STEMonstrations video series, astronaut and former classroom teacher Joe Acaba gets into the difference between kinetic energy and potential energy and demonstrates how one can become the other.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
With their spatulas at the ready, teams of students from more than 30 high schools across the country faced off at Space Center Houston recently to find the best breakfast entree to send to the crew on the International Space Station. Take a look at the action from the 4th annual edition of this one-of-a-kind culinary challenge. While missions continue on the International Space Station, NASA is preparing its next class of space travelers for future spaceflight assignments. Recently, the members of the 2017 astronaut class completed their first year of astronaut candidate training at the Johnson Space Center in Houston. Here is a look at that next group of space travelers as they moved out of the classroom and into more hands-on training.
First 6 months, we were really getting our feet under us, just getting to know one another, really doing mostly classroom type training.
Next 6 months has really picked up the pace a lot, and we've covered so many different things. Everything from learning to do spacewalks in the neutral buoyancy lab, a giant swimming pool.
The first dives were incredible. The team of people that work at the Neutral Buoyancy Laboratory are amazing. They work really hard to make it as much like space as possible, like doing a real spacewalk.
Getting in the suit for the first time was just really surreal.
We get into the suit, you get pressurized. It's a really cool experience to finally get in that spacesuit for the first time.
Totally unreal. I remember being in the pool and looking at my hands, and they have actual spacesuit gloves on, and just thinking this couldn't possibly be real life.
We went to New Mexico to study geology, but first of all, we spent a week here at Johnson Space Center working with an incredible group of PhDs that taught us geology, very intense week-long class.
We went out to the upper gorge region of the Rio Grande del Norte, and for that, it was really cool because we went to a region that had a lot of volcanic activity, and we're basically trying to piece together the story of how that region formed.
We were broken up into teams, and we got to actually go out and map different structures in the field, pick up rocks, break them open with a hammer, and actually form our own hypotheses, and then set about trying to explore them. It was a really great experience.
KSC trip was incredible. Getting out there, and for me, the first time to get to go out and touch rockets was really incredible. We get to see capsules, we got to see CST-100, we got to see SpaceX.
For me, I had never been there before. This is, the site where we've launched so many incredibly important missions through NASA's history.
I had been there back in 2006 for a shuttle launch, and to be back almost 12 years later as we're getting ready for a commercial crew to launch from Cape Canaveral again, you could sense the excitement building in anticipation for that. So that was really cool to see.
And it was really exciting for me to see just how alive it really is today, all of the different vehicles that are being built and being launched right there at Kennedy.
The land survival trip, we went went to Maine for that, where the military does their survival training as well.
And that entailed a lot of learning things like land navigation, how to build shelters, but it was also especially important for team building and group dynamics. It was a great way to bond with the whole group. A few of us have also gotten a chance to work at Ellington Field doing field maintenance, it's called. So using the T-38 as a way to train on mechanical tools, doing repairs, learning things like sheet metal work, and just generally getting to know also some of the mechanics at Ellington Field.
And on Friday, I have my first, what we call an integrated mastery. So it's going to be me in the mock-ups behind us with a group of 20 to 30 instructors as I go through my first exam, first major exam for the International Space Station.
Across the board, one of my favorite parts of this job has been getting to know my other classmates. Everyone is so collaborative, really working together to lift each other up and building on each other's strong points.
This group has been incredibly close, and every single one of us adds a lot of value to the team, and I think that's been one of the best parts of being here and training here.
Last week, we told you about the Project Mars International Film and Art Competition, which was designed to allow college students and early career professionals to learn about NASA's plans for Mars exploration and create their own vision of that future. Well, of the 120 films submitted, 24 of them were sent to a panel of judges from the aerospace and film production fields. The winners were announced a few weeks ago. They'll all be screened this Sunday at a special Washington, D.C. event sponsored by the Aerospace Industries Association and National Geographic. Last week, we showed you the grand prize winning entry. Today, for your consideration, here's one of 3 Judges' Prize winners, 9-2 Mars.
Is this Mars?
Yes.
Woohoo! We made it to Mars!
The things that you leave behind, the ones that really matter, they find a way back to you, but not how you think. And I thought I knew. Since I was 3 years old, I thought I knew what was going to be the greatest adventure of my life. When I was 7, I built myself a rocket, strapped it to my back, lit it up, and like the sun, it never ran out of fuel. I built my dreams on the foundations laid by the brave, the unconventional, the ones that reached and touched the stars. I studied the lives of the world makers. I read the books that shaped society and mastered the principles that keep in balance the universal chaos. I pushed my body to reach and share the company of the fastest, the strongest, the ones that know no defeat. And I did all of that, knowing that one day, all of this will become the foundations of a new. And I did all of that, knowing that one day, I would have to say one last goodbye to the ones that I loved the most. But I was unstoppable. And one day, I was there. I had imagined myself so many times. I would look out the window and see what no one else has ever seen. Every moment of my life would be like no other in the history of mankind. I embraced the endless day of the journey ahead. I remembered the stories of the heroes that gazed at Earth from among the stars and the lessons they learned. And I wondered, how would our lives be there? On that, the fourth planet from the sun. The red planet. My new home. I thought I knew, and now I know. The greatest adventure of my life started the day that the things I left behind came back to me. You see, I have a new rocket attached to me, one with the brightest flame, one with the power that reaches beyond me and embraces the entire planet. When I held you in my arms for the first time, I felt the guilt for the things you'll never get to see or feel. The rain, the mountain breeze, the ocean mist, a swim in the ocean, But then the guilt went away. Because throughout your life, the trails you'll walk will be the ones you'll make. The caves you'll explore will be the ones you'll find. You will get to see, to climb the highest mountains in the whole solar system. And you will be the first to experience all the unknown wonders that lie before us. You will be unstoppable. You, the greatest adventure of my life.
Let the journey continue.
You can get a look at the other prize winners and all of the finalists at the website projectmarscompetition.org. You can learn about the whole project there, and you can also see all the winners in the posters competition, projectmarscompetition.org. You can also see all those finalists at the same spot you go to get another look at any of the other stories we featured today. Check us out on YouTube and Facebook at the addresses that you can't avoid seeing right there on the screen. And while you're there, take a look at all the other cool stuff you will find about NASA and America's human spaceflight program. Now, while you're bumping around the interwebs, also check out Houston, We Have a Podcast. That features folks here at NASA talking about their work in all aspects of space exploration. Brand new episodes post every Friday. Today, Gary Jordan talks with Greg Holt of the Orion program about developing the system to allow Orion astronauts to communicate with Earth when they're in the neighborhood of the moon and when they're way out in deep space. Go to nasa.gov/podcasts, where you can find today's episode and all of the Houston We Have a Podcast catalog, as well as the full library of all of the NASA podcasts. Of course, you can also listen to any of them on Apple Podcasts, Google Podcasts, and SoundCloud. This is Mission Control, Houston.